you could write it as 2 pi over t times amplitude. So then, if you wanted to, this is, I won't do this because this is where it gets fairly complicated. Then you can come in here and say, okay, well, kinetic energy is 1/2 mv squared. So then you can substitute all of those values into the 1/2 mv squared, and like you get butt squared a squared, you get 4 pi squared over t squared times a squared, 4 pi squared over frequencies times a squared. So the whole point of this is that as you go through the equations on this assignment, you can't get locked into going, oh, here's just one equation. Vmax just equals this, okay? You've got to be able to roll this into a whole bunch of different situations. Yes?
So are we going to have to remember all these different forms?
I won't give you, I'll give you the vast majority of them. But what I would probably do is say, okay, hey, you know, omega equals 2 pi f. Now, at that point, I would be able to expect that you could do a substitution in for omega or something like that, come up with the other ones.
Okay.
Okay? But let me put it this way. I'll give you certainly all the tools necessary to end up with every one of these.
Okay.
Okay. All right, so one last problem to kind of go over, and then we're done.
We fly.
Are we ever done?
Well, that's good. That's a good point.
It's a very pale blue.
47.
Yeah.
Just to make sure.
You should probably go and send this to
They'll track us down.
Mish Kastman. Mish Kastman.
You didn't
Miss
realize
Catherine.
the secret.
Are you
Why is English such a hard language? Nope. Nope.
I can explain this.
Because as Miss Borrego puts it, English is the illegal chance child of all the other languages of the world. Yep.
I had better explanation. However, it is not safe for work.
And we're on camera.
Hello. Hello, people. Would you like to hear me
No.
say something? Would you like to hear me talk in English language? Yeah, I know. They can't see me. I mean, they can't hear me.
gonna edit you out, right?
Edit the video.
Okay. So, let's say that you have a spring that can oscillate back and forth with some amplitude. And you know that that spring is halfway through that maximum amplitude, okay? So, and that's the only thing you know is that you're halfway through that amplitude. So what I want to know is, based upon that, what fraction of that energy is kinetic energy and what fraction of that energy is potential energy? Or is it just half and half?
Are there radicals?
I don't, like radicals, like physicist radicals, or?
In the answers, is it like radical battery or something?
Radical, man.
No, there are no radicals in the answers.
I'm guessing it's not half and half. That's-
I don't know.
That would be too easy. There's
Would
no
it
way.
seem reasonable that it would be half and half?
That's too easy. This is physics.
Huh?
It seems
That
reasonable.
does seem
So
reasonable.
it's probably.
It does seem reasonable.
But you've
Okay.
trained us
But
it's unreasonable.
Sorry.
Okay?
This is like.
Now, here's the deal. So, which type of energy could we find?
kids.
Us or KT?
Us.
Us, right? So us is going to equal 1/2 kx squared, right? The generic way to calculate potential energy stored in the spring, right? Here we go.
We don't know X yet.
Well, you do,
Sort of.
because x is going to be 1/2 of your amplitude. True? Okay?
Do we know what the K is?
So
It doesn't matter.
1/4
Okay.
We're assuming K is given.
Wait.
Okay.
Really doesn't matter. Okay?
1/3.
So this is going to be 1/2 k times
1/2 the amplitude squared.
1/4.
1/4
Amplitude squared.
a squared, right? Which you can write as 1/4 1/2 ka squared. Now, what does 1/2 Ka squared get you? That gives you your maximum energy, right?
Oh,
So,
so it's 1/4.
This 1/2 Ka squared gives me my maximum energy. True?
Yeah.
So what we're saying is that 1/4 of the maximum energy is us, right? So 1/4 is gonna equal U, right? So if 1/4 is U, how much is kinetic then? Yeah, so we're gonna have 3/4 as kinetic energy. Okay? Seem reasonable? Okay. Now, where
Is my little dog gone? Where can he
My
be?
son.
Stop.
You see my son?
Where is the sun?
I would like to know where Russell Wilson's son. I would
Well, I'm gonna guess it's somewhere
The answer was frog. Frog.
there-ish at this point.
That's such an obscure
Huh?
You're trying to
Yes,
figure out
where
where
the
the
sun is. I'm guessing it's somewhere around there.
That's a good idea.
Wow.
Okay. So, if it's at halfway, it's 1/4 U and 3/4 kinetic. Now I want to know, where could I put it where the energy is actually split between 1/2 kinetic and 1/2 U?
3/4 A.
You gotta do root 2.
1 over root 2 in terms of amplitude?
Yeah, 1 over
or
root 2 amplitude.
why?
Frequency.
Root 2 squared
Because
is
when
just
you
2.
square it, it'll turn into 1/2.
Yeah, that.
It'll
That's science right there.
No, that we're good. Okay. So here's the deal, right? So you want half the energy to be us, right? Okay? So you want 1/2 of 1/2 Ka squared. True? Okay?
We solve for A.
Now, that has to equal this generic type of energy, which is going to be 1/2 Kx squared. And then if you do all this rigmarole, you get 1/4 Ka squared, right?
Wow.
Ribbon roll?
So then the K is going to cancel out, and you get x squared equaling, because if I multiply that by 2, I get 1/2 x squared. So x is going to equal the square root of a squared over 2, which is going to be a times 1 over radical 2.
We knew it.
Take that.
Okay. So yeah, so because of the fact that it's squared, as soon as you put that underneath the radical and square it, then that becomes 1/4. Okay, got that? Life's good? All right.
That's the way it is.
Now, because this took, there's a whole bunch of people down, so I was gonna go over some stuff, but we'll just kind of save that for tomorrow. So, and this assignment's gonna take you a while anyway.
And we're leaving in about half an hour. Along with Noah. You still need that?
If this was like A push, I'd be getting tired. I feel like.
Yeah. Noah. Do you need a ride?
No.
Okay.
Because you guys have to leave early anyway, don't you?
In 30 minutes, yeah. Ish. We're gonna have to go through the office.
Wait, we're doing 463 questions?
No, that's page 463. Good grief.
Okay.
463 questions later.
You have to live in the valley.
Where am I?
This looks like
When am I? You've been here for 30 years. Doing homework you didn't need to do.
Substitution still.
I hate it. Mia, Mia. Now you sound like a really crappy version of the one, that lady with the big glasses from Star Wars. The sequels.
What are you talking about? I'm you
Maud?
in 30
Was that the gal's
years.
name? Was it Maud?
Maz or Maz or something. I don't remember. Katana.
You 30 years in the future.
No, you're not.
Oh, sweet cheese and crackers.
P. 14.
Okay. So this will make sense when you get to question number 3. In the book, they define going right as being positive. That'll make sense when you get there. And then you got the questions and the problems. And basically, all of these are either brought to you by an oscillating spring or a period of a pendulum 2-pi times the square root of L. Okay, that is 80% of these problems.
Okay, I can't see that. Okay.
1, 2, 7. There's no 3.
Well, today, physics has more problems
You messed
than
up the
calculus.
song.
It was opposite yesterday.
1, 2, 7, 3 down on Rockefeller Street.
I'm taking away your voice privileges.
Yeah, I agree.
Your thinking privileges have been revoked.
Huh? Oh,